Okay, so now we're going to move into solving by substitution. So it's a little different from graphing. We've got to use a little bit more algebra here. We're going to start off by trying to get one of the equations to have a single variable on one side. So this is actually perfect because y equals 2x plus 5 already has y by itself. What we want to do then is say, okay, if y equals 2x plus 5, I can then change this y to 2x plus 5. And I can rewrite this equation as 3x plus 2x plus 5 equals 10. So all I did was plug in this 2x plus 5 up here into the y right there. And now I just need to combine like terms and solve for x. 3x plus 2x is 5x plus 5 equals 10. I'm going to subtract 5 from both sides. 5x equals 5, and then I'm going to divide both sides by 5, and I get x equals 1. I then take this and plug it back into the first equation, the original equation that I used to solve for y. So I get y equals 2 times 1 plus 5. Y equals 2 plus 5. I get y equals 7. I can check this by plugging in x and y into one of my equations and making sure it works. So I will plug in 3 times 1, since x we got was 1, plus 7 equals 10. 3 times 1 is 3, and 3 plus 7 is 10. So we got the right solution. So we say that the solution to this, we've put it in coordinate point form. The x is 1, the y is 7, and that's our solution. So if we were to graph these, this is the point where these two lines would intersect. Just solving for it a different way than graphing. Alright, pause the video now and try this one on your own. And when you are done, you can hit play and see how I did it. Okay, so we've got two equations here that they want us to solve using the substitution method. So we have to use substitution. I have x minus y equals 3 and x plus 2y equals negative 6. It does not matter which equation you decide to use first and get the variable by itself. I'm going to use x minus y equals 3 to try to avoid negative signs. I'm going to add y to both sides, and I get x equals y plus 3. So now I have my x by itself. I can take this part that x equals and plug it back in to the second equation above for x. So I get y plus 3, that's what I plugged in for x, plus 2y equals negative 6. I can combine like terms. Y plus 2y is 3y plus 3 equals negative 6. Subtract 3 from both sides. 3y equals negative 9. Divide both sides by 3. Y equals negative 3. So now I need to plug in y equals negative 3 into my first equation and solve for x. Or I can just plug it back in to this equation and get x as well. So let's try both ways and make sure we come up with the same answer. If I plug it into this one, I get x equals 0. If I plug it into the first equation, I get x minus a negative 3 equals 3. That becomes x plus 3 equals 3. And I subtract 3 from both sides, and I still get x equals 0. So I think it's pretty safe to say x equals 0. But let's double check that the negative 3 is actually correct. So let's plug this back in, and we'll plug it into the second equation this time. We plug 0 in for x, plus 2 times negative 3 for y, equals negative 6. I get 0 minus 6 equals negative 6. That's negative 6 equals negative 6. And I think we did that correctly. So we'll write our solution in coordinate point form. and we would put a 0 in for the x and a -3 in for the y. And that's our answer. I hope you got the same thing. See you tomorrow in class.